Hi everyone, welcome back. So today I'm going to show you how to interpolate point data. Since we already downloaded the precipitation data, right? You can see in the map that these are our rainfall observation station that we already have downloaded. So what I'm going to do, if you want to even calculate the basin average precipitation from these observed gauge stations, because we can even calculate the basin average precipitation from a gridded data, right? We already have idea about that one. So if I want to even calculate the basin average for each of this basin or sub-watershed from this available point data source, so how can I do that? I have to interpolate, right? So this interpolation will be a spatial interpolation. So there are several methods that can interpolate very accurately. We'll check. So Thiesen Polygon is one of them. So first we'll see how it looks like and how can we interpolate or precipitation from these available point gauge stations. So first we'll use Thiesen Polygon method. So that is called triangular interpolation method. Okay, so what I'm going to do, I already selected that sub watershed. So in order to proceed with Thiesen Polygon, you need to have your stations, right? You can remember that. If I want to open that table, you can see we have the station name and we have the latitude, longitude, but what we processed after downloading that CSV file, we have this, right, annual precipitation in terms of inch. Okay, these are the annual precipitation for these 13 gauges. So we'll use this precipitation and we'll distribute that one using our Thiesen triangular interpolation method. And in order to do that, we need to have our point gauges that we already have here. You can see that, and we need to have our sub watershed, right? So we have this sub watershed. I don't want to turn on that one because we need only this sub watershed. And if I open that sub watershed, you will see we have the Hawk name, Hawk 8, Hawk 10. This is the preliminary one. I'm just importing this one. So based on this Hawk 10, I'll calculate the basin average after interpolation. Okay, so in order to do that, we have to select these two, the point and control and that sub watershed, and then go to your arc tool and find that analysis toolbox. We have different one, right? At the very beginning, you can see we have that analysis tools, and then what we have the proximity. Here we have the proximity. If you click on that, and you can see different options, right? Here, create Thiesen polygons. At first we'll create that polygon, and see if I double click on that, it will open this window. And before selecting the input feature and output feature class, what you have to do, you have to keep in mind that we have to even select that processing environment. So I'm clicking on environment and then click on that processing extent. Okay, and then you have to select the extent as same as display. If I want to select same as display, here it is, and then select OK. So what it will do, it will do the processing based on this display selection. Okay, so now I'm gonna select that input feature. So what will be our input feature? That is the precipitation, right? That precipitation state plane, because I already projected that one. You already did the same thing, right? So I'm selecting the input feature, the precipitation stations, and then it will do the job for us. That's why we selected the display, because it will use that display sub watershed. So here it is. I'm gonna select the name as Precip Thiesen, because this is the precipitation. So it will be Precip Thiesen. Okay, Precip Thiesen. And then here what we have to do, you have to select other options, all, not the FID, because I'm gonna preserve all this information from that attribute table of precipitation. If I click OK, so it will start processing. Let's see. Don't forget to use that processing extent. Okay, so it's calculating and it is gonna give us the processing extent as our, see, this is the Thiesen polygon. So that is what we have. So now if I open the attribute table of Thiesen Polygon, you can see it is also a shapefile and it is preserving everything. So it generated based on that precipitation stations. Okay, so now what we have to do, we have to select, because if I make it hollow, you can see we have, right, and make it hollow. And can you see that if I just increase the weight of the width, see, it is just interpolating, right? It is even covering our study area and the polygon, even it is considering the outside of our study area. So that is also necessary, because if we have some observation that is close to our study area, so we can even consider that one as well, because we are interpolating everything. We are distributing especially our precipitation to compute the unknown watershed, the values over unknown watershed. So that is our goal. So now what I have to do, I have to even intersect, right? So I have to cut the pieces that are just intersecting this Thiesen polygon and this sub-watershed, right, for our study area. So in order to do that, now I'm just intersecting two shape files. So what we have to do, we have to go to analysis tool again one more time, and it is there, right? And if I click on overlay instead of proximity, so because we are selecting the intersection, and then if you see, we have one option, intersect. If I click on that, so it will open the window, and here we can select the two options that we need to interpolate. What we need that precip Thiesen, right? That one we need, and we also need our watershed. So we need to select the interpolation boundary in between these two. So San Jacinto sub watersheds, I'm selecting these two, and if I just save this as precip Thiesen intersect, that's okay, and I'm just keeping everything as it is. Okay, then if I select okay, so it will even intersect in between these two. So let's see what it is doing. It is selecting, maybe it's done pretty quickly. You can see that if I turn off the Thiesen polygon, now we can see we have only, right, it is just, it cut that portion outside of our study area. That's why we just selected our study area and the Thiesen polygon. That's what we need. Now what we have to do, and if I open that attribute table, say it is the combination of these two, you can see that it is including the precipitation that we have from our precipitation. That's the field we need, see, and even it's increased the number. Previously we had few, but now we have 7D. Okay, so it increased because it is selecting only the boundaries, and it created that. This is the intersection of these two. So now what we have to do, we have the Thiesen precip intersection, and now we have to do some processing to calculate the basin average of each of this sub watershed. That is what we need. So we just interpolated our gauge precipitation, and we distributed it as using Thiesen polygon. Then we intersected the Thiesen polygon with our study area. Now we have the data set within our study area. So we have more sub watershed. So now what I'm going to do, I'm going to calculate the basin average precipitation. So what we have to do, we have to do some calculation here, and in order to do that, I'm going to show the equation based on which we'll calculate that one. So this is the equation we'll use to calculate the basin average precipitation. So what I have to do, I have to use the area of any specific watershed, that is called I, and the P is for that specific precipitation, annual precipitation for that specific watershed. And if I just multiply this area by that precipitation, and if I sum them up, and then if I divide this by the summation of the area, then I'll get the average, basin average. So that is the equation, we'll use that. So in order to do that, what I have to do, I have to add the field, right? Where? In our Thiesen intersection, because we have the intersection in between our study area and the precipitation. So we'll do everything there, because we have the Hawk name here. We also have our annual precipitation. So now I'm going to add one field. By this time you have idea about how to add a field, right? So the name of the field will be kind of a product, means area and the precipitation, and then product, PROD, and that field will be double because it may be float, decimal will be there. So I'm selecting that. We have added one field at the end of this one, right? So we have to fill this up. How can we do that? Right? So what do you have to do? We have to use our calculator, right? So it's there. So right click on that, and then it will open and field calculator. If you open that one, then it is asking to select. So now what we have to do, we have to select that annual precipitation, right? That value of precipitation, that one, this one, annual precip inch, and we have to multiply by our shape area. Let me check the shape area. See, we have this shape area here. Can you see that? Definitely. So that shape area, we can find it even from here at the end, shape area, right? That one. So now if I click OK, so it will fill this up by the multiplication of these two. I'm just clicking OK. So yeah, it's processing. See, we have the multiplication. So what we have to do, we have to even divide by the summation of our area. So that's why we have to do some other processing. So if we want to calculate based on our HAC10, so we have some common name, right? So we have HAC10 like 8 or 20 out of this 7D. So then it will calculate that, because we already calculated the multiplication in between area and the precipitation. So it will sum them up. That's why the equation is that, right? It is the summation of the product of area and the precipitation. Then we have to divide by the summation of the area of those small subwatersheds. Then it will calculate the average precipitation for that HAC10 or HAC8, whatever the name you select. Based on that, it will create the average precipitation data. So now I have to process a little bit. So what is the next process? So we need to even sum the shape area, and we have to do, right? So if I click on, let me just open it again. If I click on shape area again, see, if I go to there, HAC10 name, find the HAC12 name and HAC10 mood, and here is HAC10 name, because I'm gonna calculate the basin average based on HAC10 name. The names are there, right click, and then if you click on summarize this time, then we'll have different options, right? Here we can select our shape area. Can you see that? Definitely we can see the shape area, right? We can see the shape area and we can see a product. So here is the shape area at the end. If I click there, you can create, right, new variable. You can calculate minimum, maximum, average. So I'm going to calculate the sum, because in the equation we saw we need to have the summation of the shape area, right? And what we need to have, even we have to select this one as well, the product of this precipitation and the area, and we also need the summation, right? Then we'll divide this sum by that area. That is the equation, and we have to save this, right? We have to save this, and this will be one table. So what will be the name of the table? So this will be like watershed precipitation. Okay, so watershed and precip, watershed precip. I'm saving this way, and it is gonna save. If I click OK, so it's done, it's processing. Okay, I'm gonna add it to our map, definitely. So it's added to our map. Let me close this one and see. If I open that, it will open. See, now what we have the sum area, and we have the sum of the product of area and the precipitation. Now I have to even divide, right, this column by this column. Then I'll get the average precipitation, basin average precipitation for this HAC10 name. So in order to do that, what I have to do, I have to add, right, another field again, and that will be our precipitation, basin average precipitation. I can, okay, BA means basin average precipitation, and I'm going to select it as double as usual, and then we have that one. So now if I click and select and right click and then field calculator, what I have to do, I have to select this one, sum a product, right, it's there, divided by that sum, right, shape area. So that one, it's already there. So then it will, so this row, this value will be divided by this one, and it will put it there, and this value will be divided by this one, and the value will be put right there. So on and so forth. So let me click OK, then we are done. See, now what we have this one, this is the basin average precipitation. So if you know this value, you can use it in your model. So we used a different code mathematics, right, to calculate. So this is the basic one to calculate the basin average from point gauge data. If you have your point gauge data, so if you have more points, then your value will be more accurate. So we are just distributing using different methods. So Thiesen Polygon is one of them. So now we know how to calculate, and if you want to even export this table, you know that, right? How to export it. So if you click on that arc toolbox, and then if you want to export the table as your Excel file, then table to Excel, and then select the required table. It's there, watershed abrasive, and where do you want to put it? Is there, right? If I save it, it will be there. So I'm saving it, and maybe it's saving, and let me check. It will be there. Okay, let me check it. So it should be there inside my here. See, it is there inside this one. So that is the table we have. See, now you can process. Okay, this is my basin name based on HARC10, and I have this average basin average precipitation. Now we'll select another interpolation method. Okay, so that is called Thiesen Polygon. So we are keeping this in mind. We have the Thiesen Polygon. Now we'll select another one. It is called Spline Interpolation. So how can you do that? So we have to go for spatial analysis tool. Okay, so that's what we need. If you can't find that one, you have to go to customize and extensions, and then out of this extension you have to turn this on, then you will find it there. Click on arc toolbox and go to there at the very bottom of the list, and then spatial analysis tool, and out of this tool you have to find out that interpolation, and here it is. You have the interpolation, and then you'll find IDW, means inverse distance weighting, and then Krigging. You have other natural neighbor, you have a spline, right? Spline with barrier, you have topo to raster, you have topo to raster by file, and if you have trend analysis, you have this. So I'm gonna select that one first, splines, then I'll show you how to do that IDW and Krigging. These are the popular spatial interpolation method. Okay, I'm gonna select that one, splines first, because our study area is like that one, like splines. So I'll select that one. Otherwise, if I select IDW and Krigging, you'll see it will create square shape. So that's why we need splines. So it depends on your shape and study area necessity. So at the same time and same thing we did it, right? We have to select our environment first, go to environment, and then the processing extent at the same time. So it will be always, most of the time, same as display. So we're done with that one. Now what do you have to do? We have to scroll down to raster analysis, right? So go to raster analysis, and then you'll find out that what will be the mask. Okay, in the mask you have to select that watershed, means the watershed we have for selected one. So San Jacinto sub watershed for this case. Okay, so now we have the watershed as mask, so it will use this watershed as mask. So the same thing we did for, right, extraction by mask for extracting the DEM data or any raster data, right? So our environment is done. We're selecting OK. Then here the input feature, we'll select our precipitation, right? The precipitation we have here. Then we'll select the field. So that is the precipitation. Which one we need to select? The annual, right? That precipitation, because this is different interpolation method. And what you're gonna do, we can keep the output cell size as it is, and everything is same. But here spline type, so this spline type should be tension. Then it will fix that area. Okay. If I select tension, if I want to see what it is gonna do, show help. See, it is gonna do this thing. So always you can select, say if you select regularize, so it will yield a smooth surface and smooth field derivatives. However, if you select tension, it will just tune the stiffness of the interpolant according to the character of the modeled phenomenon. Okay, so that's how we need to do that, and I'm keeping the field as it is, 0.1 and 12, and it is gonna save the spline here, right? And I can select it as annual precipitation, because this is another interpolation method, and we are interpolating the annual precipitation, right? So I'm selecting that one, and if I click OK, so it will try to interpolate, and maybe it is gonna take a while because it is another specific interpolation method. So now we have our data. You can see this is basically a raster, nothing but raster. So we can see the map here. If I turn off other values, and we can see if I turn off that outer field, and if I turn off that one, you can see we have that interpolation, right? This is because of spline, and it selected this path, and these are the precipitation, and basically these are nothing but raster. If I just modify the field a little bit, symbology, and here if I select the label and format label, and in order to do that, if I just select like 3 or 3, then it's gonna give us this one. Okay, now it's pretty good. And if I wanna even select the Thiesen Polygon this time, which one is that, right? Passive Thiesen. This one is bigger, but we have the smaller one, the intersection, right? This one we have. And if I even make it hollow, and you'll see this is pretty good, right? See, you can see now it's looking like pretty good. So Thiesen Polygon, what it did, right, is just we have this polygon there, we have one station, so it created the basin average considering this polygon within this polygon. So see, it considered and it calculated one polygon and created one polygon for one point gauge. See where we have the more weightage, so it is the value is, see, higher. You can see the legend here. So that's the map from Thiesen Polygon. And if you want to even create the zonal statistics and basin average based on that one, you can do the same thing. So we have the distributed value, we have the raster right now, and we can even create the zonal statistics as table. That is another way to calculate, right? We already have idea about that one. So the zonal statistics as table. So I'm going to show you everything. So what will be the input feature or raster? It will be based on our sub watershed, right? This sends us into sub watershed, and the zonal field will be HAC 10 or HAC 8. Okay, HAC 10. Based on that one, we can select an input raster because annual precipitation, this is now input raster, and previously we already have idea about how to create zonal statistics from DEM, but we don't use that one. So this is the real example of zonal statistics where we use precipitation data most of the time. If we have point data, we interpolate it. If we have gridded data, we just create grid. From grid is another type of raster. If we have netcdf file, so from netcdf file we create a raster, means the T file, and then we can even calculate the basin average. So that is zonal statistics, and I'm gonna calculate all value as before. If I select OK, so it will calculate and it will give us the same annual precipitation. See, if I just select that one, open it, now we have based on HAC 10 ID, and we have our mean annual precipitation. See, this is the HAC 10, and if I compare these two, compare between what we have previously and in between these two, so what I'm gonna do, see, I'm making it like short, and I'm gonna open that Excel file at the same time because we have the Excel file, right? We already said that. So this is from Thiesen Polygon, and this is from Spline Interpolation. So which one is bigger? We can even compare, right? We can even compare. See, where is the Excel file? So there it is. See, I'm putting it side by side. So that is the mean value, and that is our value for this one. Okay, so which one? Basin average. The first one is 46 from Spline, and here is 48, and right for that case, and the last one is 54, and here it is 53.92, almost same. See, a little bit different because which one is perfect? No one. But if you have more value and if you have less, Thiesen Polygon is important, and for irregular shape, so we can use this splines. So these are the ways to interpolate. You have to select, that's why we have different options, right? And if you want to even calculate this, even you can select other method as well. Krigging, you can select the Krigging method as usual, right? Okay, let me quickly show you that one as well. Interpolation, where is the interpolation? We selected there, and we have even so IDW, that is the inverse distance, right, weighting. If you want to calculate the precipitation for this one, and if this station is away from this location, so it will use less weight, right? That's even reality, because we are gonna make the average value. If it is away from this station, then definitely in between this station, the relationship, this precipitation will have less effect there. So it will consider this station more, right? So it will give you the more weightage here, right? So if the distance is 100 kilometer, and if I want to calculate the value here, and if this station is like 40 kilometer from there, and if it is 60 kilometers from there, so definitely the average value will be more based on this one rather than this one. So that is called inverse distance. And if I click that one, so let me quickly show you the input point feature, same as precipitation, that one, straight plane, and I'm not gonna change the name as before, right? So what will be the value? Okay, so same as before, if I close it, we have to select, right? So the precipitation and our sub watershed, I'm gonna turn this off, just a control and select that one. I'm gonna turn this even off, this one, and now I'm gonna select, so it will understand that this is our goal. So we have to select the processing unit and environment. We don't need that, because if you select that one, it won't work even. So we can even select the straight plane. Zonal field will be that value of the precipitation, and it will be by default that one. I'm leaving everything as it is, okay? And then if I click OK, so it will be based on IDW. So that will be like rectangular thing, not like the one we have. See, it is covering our area, but even it is excluding other portion. So it is considering everything just at the outside of our, right, precipitation. So it is considering that is as a border and is not going beyond that station. So that is the demerit we have. So we have to decide which one you are gonna select and which one you should select, or right, see, that is the case. So I'm gonna turn this off, and if you select even Krigging, it will give you the same type of thing. So which one is better? From my understanding, it is better to use splines, okay? And if I select the same thing, precipitation, and I'll give the same name here, if I select OK, so it will give you the same type of interpolation. So IDW and Krigging, these are almost same. Most of the time we use this thing in hydrology, but we can even see that is the Krigging. So which one you are going to select? From my understanding, I'll definitely select that spline. So it is looking like a PRA, right? We can select this one. So that is pretty good. And we can even use our Thiesen Polygon intersection, this one. So we can change the name of our map. It will be like annual rainfall, right? It will be annual rainfall distribution. Distribution and Thiesen Polygon. So that will be our name of our map. So it's good, right? Yeah, and you can even change the legend type. You can select, you can make it bold so that it is pretty clearly visible. Even you can drag it down. You can do all this processing to fix the extent, right? We can do this type of manipulation. We can do this. So that's that. You can try by yourself. So this is one which is very important, because previously I was always trying to say that if we have any point gauge and if we don't find any data that is basically from different sources, and the data should be gridded, so how can we even calculate our basin average precipitation, right? So this is the way. Even if you even have less than this number, we can use that interpolation, so it will do the same job for you, but the accuracy won't be that much good. So that's why it is better if you find more station, use more station even outside of your study area, because if your study area boundary is there and if you have one gauge there, don't exclude that one, consider that one, because it is the precipitation. So there will be some, right, spatial distribution from this one, and it will even contribute some of the weight, right, to calculate the precipitation here. Because if you want to calculate precipitation from this station, so the distance from this station here, it's close from this one, so the contribution of precipitation, if you consider this one, that will be more accurate than this one. So that's why it doesn't matter wherever, right, So where is it, where is your station area, it doesn't matter, or where is your gauge location, it doesn't matter. Try to consider every station, whether it is outside or inside of restored area, it doesn't matter. So that's that. You can try by yourself, and in the next tutorial I'll try to show you a different thing, right? So we are gonna finish off here the labs 2. So we are done with lab 1. We downloaded our data, we process it, and in lab 2 we downloaded the DEM data, we downloaded our precipitation data, and we also demonstrated how to project DEM, how to create even flood inundation map, and we also downloaded rainfall. And today we saw how to just interpolate especially the point gauge data and create the basin average precipitation, right? Either using Thiesen Polygon or Spline or IDW or Krigging, anything you can select. So that's that. You can try by yourself and let me know if there is any difficulty. And thank you very much for watching, and I'll see you in the next tutorial. Stay safe until then. Bye.